everyone. My name is Aditi Ravichandran and welcome to my course GraphQL The Big Picture. I'm a software consultant, speaker, blogger and a passionate teacher. You can follow me on Twitter at Aditi Ravi or visit my website aditiravichandran.com to learn more about me. Are you curious to learn about an alternate approach to REST? GraphQL is a query language for your API. Did you know it gives clients the power to ask for exactly what they need and returns exactly that? Apps using GraphQL are fast and stable because they control the data they they get. If you want to learn more about GraphQL and find out if it would be a good fit for your business needs, this course will be right for you. In this course, GraphQL the Big Picture, some of the major topics that we will cover include a big picture overview of what is GraphQL, learn GraphQL core concepts, and then we will talk about why GraphQL, and finally we'll look into the diverse GraphQL ecosystem and tooling. By the end of this course, you'll have a solid understanding of GraphQL and its power. You'll be able to decide if GraphQL is a good fit for your business and team. I hope you'll join me on this journey to learn GraphQL with GraphQL the Big Picture course at Pluralsight. Hello, welcome to my course on GraphQL the Big Picture. I'm Aditi Ravichandran, a software consultant focusing on front-end development. You can follow me on Twitter at Aditi Ravi, or you can visit my website aditiravichandran.com to learn more about me and read blog posts from me. If you're taking this course GraphQL the Big Picture, I'm going to assume that you have no prior experience with GraphQL and are curious to see what it's all about. This course targets CTOs, software architects, and developers who are evaluating an alternative to REST for their API layer. GraphQL has gained immense popularity in the last few years and is a powerful alternative to REST. Many Fortune 500 companies are using GraphQL today in their products like Facebook, PayPal, Twitter, and many others. In this course, we'll learn about what is GraphQL and get a big picture overview of GraphQL. We will explore the core concepts of the GraphQL specification and learn how to write queries and mutations. We'll also learn about why GraphQL and how it helps your product development. Finally, we'll dive deep into the diverse ecosystem of GraphQL. By the end of this course, you'll have a good understanding of GraphQL and how it differs from REST. You'll be at a good spot to decide whether GraphQL is a good fit for your team and for your company. In this module, I'll introduce you to GraphQL and the introductory concepts of GraphQL. We will then go over the history of GraphQL and how it came about. Next, we will look at who is using GraphQL today and their success stories. We will then learn about how GraphQL differs from traditional REST APIs. We will compare them to understand why GraphQL could be a better alternative to REST. Finally, we'll go over the typical use cases of GraphQL and when it is a good fit for you and your business. Before we get started to learn all about GraphQL, let's look back at the history of GraphQL. Back in 2012, Facebook started GraphQL as an internal project. They started the GraphQL project to overcome data fetching issues in their native mobile platform. GraphQL was Facebook's opportunity to rethink mobile app data fetching from the perspective of product designers and developers. It moved the focus of development to the client apps where designers and developers spend their time and attention on. In 2015, Facebook open sourced GraphQL, and ever since then there has been a huge community involvement with GraphQL. Today, there are a huge number of tools and libraries that have been developed to support the GraphQL ecosystem across several languages. GraphQL came into existence due to the need for better flexibility and efficiency in client-server communication. Today, GraphQL has become comparable or an even better alternative to REST APIs, with a wide adoption among several Fortune 500 companies. So what is GraphQL? We looked at a brief history of GraphQL and learned that it was invented to attain better flexibility and efficiency between client and server interactions. GraphQL is essentially a query language for your API. That's right, it's just a specification and a query language for your API. It's not a library, it's not a product, it's not a database. It has been developed as a more flexible and efficient alternative to REST. Let's look at how things work with APIs today to better understand GraphQL. With regular REST APIs, we hit what is called an API endpoint from the client, and the API returns a massive JSON object with a lot of things in the response. This is what we've been used to for many years now. So what makes GraphQL new, exciting, and different? Instead of hitting a URL endpoint and getting a massive JSON object back, GraphQL lets you write a query to request for exactly the data that you want and receive the results back with just that. Isn't that exciting? Let's take a look at this example query below to better make sense of what makes GraphQL unique. This is a sample GraphQL query. Here, I'm requesting for people information from the All People API, and I just want the name and gender. I don't want any other information, even if it's available. You can see here that I'm passing an argument to request only for the last 3 people information. Now, let's see what the GraphQL response looks like. The response that I receive back is a JSON object that is structured just like the request. Notice here that I get exactly what I asked for. Nothing more, nothing less. I got the last 3 people information with just their name and gender. From the previous example, we've learned that GraphQL provides clients the power to ask for exactly what they need and receive the response with what they asked for. Nothing more and nothing less. This is one of the most sought after features of GraphQL, owing to its popularity. Another interesting aspect is with GraphQL, you can get all the data that you need within a single request. GraphQL allows you to aggregate queries and fetch all the data in one request, avoiding multiple round trips. It is just a query language, and it is completely agnostic of the language. Due to this, plenty of client and server libraries have evolved across multiple languages in the GraphQL ecosystem. In this clip, we'll talk about who is using GraphQL. Ever since the GraphQL specification was open sourced, plenty of server and client libraries have been developed to support GraphQL across multiple languages. Just few years ago, this technology was non-existent, but today, GraphQL is used by teams big and small. It is used by many Fortune 500 companies and has replaced REST APIs. Facebook. Facebook is where GraphQL was born. Facebook started using GraphQL for services to their native app. Today, Facebook is heavily invested in GraphQL across their products. PayPal. PayPal is one of the mainstream adopters of GraphQL. In an article that describes the success story of using GraphQL in PayPal, they have described that GraphQL helped solve some of their big developer experience problems and performance issues. Isn't that amazing? They are now revamping their flagship PayPal checkout products to use GraphQL. Here is the blog post that details the success story of using GraphQL at PayPal that you can read to get a better sense of moving to GraphQL. The next big product that uses GraphQL is Twitter. Twitter even has their APIs publicly available that you can play around with. In a blog post by Twitter Engineering, they've coded that moving their clients away from the REST endpoint saved their data by as much as 25% per request. This is huge. And they also believe that another and even an app that enables of other companies, and that might I had mentioned that GraphQL is a better alternative to REST, but I didn't get to why that's the case. In this clip, let's learn about the fundamental differences between the REST approach versus the GraphQL approach. Let's say we want to access the data in the Pluralsight library. I want to build an app that displays the author information. I wanted to display the name of the author, the courses created by the author's rating, and the 3 most recent topics related to the courses created by the author. Simple enough, right? If we were to use REST APIs or representational state transfer APIs, then I would first have an endpoint with ps/author/id that fetches the author information for a given ID. I would then need another endpoint to access the courses in the library, another one to get the ratings, and finally another endpoint to get the topics covered. You get the idea. Let's take a look at this visually. An endpoint to fetch the author information. This may also return more than what we need, because all I want is the author's name, but it may return much more than that. Another endpoint to fetch the courses, another to fetch the ratings, and finally an endpoint to get the topics covered. In our app, we wanted only the 3 most recent topics covered by the author, but REST APIs would return everything that is available in the data set for this endpoint. The client then has to filter the response with what they need. REST endpoints get out of control as our data needs expand. This leads to multiple round trips and causes a slowness in response time. Now enter GraphQL. I can build the same app using GraphQL with just a single request. With GraphQL, I can compose my request in the form of a GraphQL query and ask for exactly what I need to build the app. It then responds with a JSON object with exactly what I asked for. This is amazing. This means no more multiple round trips, no more overfetching or underfetching of data. Here is the GraphQL query that we've composed to get the information about the author to build our mobile app. Let's take a look at this query here. The first thing you see is I'm asking for the author information by passing the ID. This means that I'm just going to get information about this specific author just for the type I want that. The response that you get for this is exactly what REST has the ability to ask for specific data from multiple resources. Query underfetching of data. Under GraphQL, another big point of view is stalled until the backend team gives them of mock APIs until the backend team gets back to them with the finalized APIs. This shouldn't stall any development. Spec for caching. It uses a between REST and the GraphQL approach. You might be wondering, all this sounds good, but does GraphQL fit my business needs? Is it worth it to make the switch from REST to GraphQL? Or you could be building a brand new service architecture and wondering if GraphQL is the way you want to go. One of the biggest contributions that GraphQL can make to your business is increase the multi-team productivity. Imagine how much easier life for front-end developers will be if they don't have to bug the back-end service developers for complete APIs. They don't need to wait for new versions to be released, and the teams can work in parallel, which enhances the multi-team productivity. Increased productivity among developers lead to a speed up in the product development. With GraphQL, it is possible to completely redesign the UI of your app without needing to touch the backend. Isn't that nice? The client team can code against the mock API from day one, instead of waiting on the backend teams. This is one of the biggest perks of GraphQL. With the reduction in multiple round trips to fetch data, and with no reason for overfetching data, GraphQL is naturally more efficient. This improves performance of your API calls and speeding up your app. You ask for what you want is the approach that provides better performance in GraphQL. Another good news for you is that GraphQL APIs need to be tested only when there is a change in the schema or if there is a fresh schema. This means reduced costs in testing for your business. This also holds true for deployments. Compared to REST, GraphQL is much less expensive for testing and deployments. Are you a company with a lot of legacy systems? Have your APIs grown over the years and it is almost impossible to convert them all to GraphQL now? Don't worry, you can still use GraphQL. In fact, GraphQL is a really good option at this point. GraphQL can be used to unify your existing systems and hide the complexities behind the new GraphQL API. Now, your new front-end applications can be developed to simply talk to the GraphQL server. They can fetch the data that they need. The GraphQL server is then responsible to fetch the data from the existing systems and return the right JSON back. This would be a good addition to your code, making front-end applications communication with your server much better and clear. Well, that's a wrap, and we've reached the end of this module. In this module, we learned about what is GraphQL and looked into some of the core features of GraphQL. We understood how GraphQL is unique and what the GraphQL approach is all about. We also explored some products developed with GraphQL and learned a little bit about their success stories. We then moved on to compare the REST model with the GraphQL model and explored differences. We will learn about writing GraphQL API. In this module, we're going to explore the core concepts of constructing a GraphQL query and GraphQL mutation. We will learn and understand the core concepts with plenty of examples. Alright, let's dive right in. We know that GraphQL is just a specification and a query language for your API. Before we write some queries, we need to know the different types supported by the GraphQL schema. GraphQL has a strongly typed schema, and this schema acts as a contract between the client and the server. Let's look at the types that can be part of your GraphQL schema. GraphQL scalar types. These are the primitive data types in GraphQL. Int represents a signed 32-bit integer. Float represents a double precision floating point value. And then we have string that represents the character sequence, boolean for true or false, and ID. ID is a unique identifier that we use in GraphQL, and this is usually used to refetch an object or used as a key for a cache. In addition to the basic types, you can also return objects with its own complex behavior in GraphQL. We have now created a type called author, which is a complex object with its own characteristic. It contains a bunch of items, each with its own type. It contains an ID, first name and last name of type string, a rating of type float, and number of core int. GraphQL schema, scalar types that are restricted to a GraphQL also supports enum types. Enums are special scalar types that are restricted to a particular set of allowed values. Enums in GraphQL work exactly the same as enums that you may have used in other languages. It allows you to validate that any argument of this type are one of the allowed values. For instance, we've defined an enum called language with 3 values: English, Spanish, and French. The language type is allowed to have any of these three values. Next, let's look at the two other types that you'll frequently use in a GraphQL schema. A schema can contain query and mutation types. Every GraphQL service has a query type, and it may or may not have a mutation type. The query here represents what the client is asking for, and the mutation is when they're going to add or delete data from the API. This acts as an entry point into your schema, and query and mutation types are treated the same as any other GraphQL object type. Two other types that you'll frequently use in a GraphQL schema: query and mutation types. This acts as an entry point in QL object type called author details, and a mutation called add author. Notice here that the query and mutation types are defined just like the other types. Now tweaked our author type a little bit. Notice the exclamation marks that I've added. By default, added. This makes it clear if the field is allowed. We will all field. We can even have a list of non-null items. In our example, we have a list of courses which cannot be null. This option in GraphQL was using the API. Alright, let's get started with writing our very first queries. We're going to use Graphical, which is an in-browser IDE for writing, validating, and testing GraphQL queries. We're going to write these queries against GitHub's API, and just a heads up, GitHub's GraphQL Explorer makes use of your real live production data. That's going to be fun, isn't it? You can follow along by clicking this URL. Make sure to sign into your GitHub account or set up a new GitHub account to obtain access to this GraphQL Explorer. The first piece in a GraphQL query is that you're going to query for fields. A GraphQL query is all about asking for specific fields on the object. So let's write our first query asking for specific fields on an object. Here is the GitHub GraphQL API, and we are inside the GraphQL Explorer. On the left side, you can type in your queries, and when you hit the play button on the right side, you will see your queries results. Also, on the right side, you can see a documentation explorer, and this is where you can check out all of the GitHub's API documentation. A nice thing about the GraphQL schema is that it is self-documenting, so once you have your schema ready, All of this documentation is generated from the schema. Alright, let's get started with our very first query. I'm going to query for a field called viewer, and inside that I'm going to query for login. When I hit the play button here, we're going to get back our JSON response on the right side. It returns the login ID Aditi Ravi because remember, I've signed in as me and that is live data, so it gets my login information. If you wanted to, you can also further explore the documentation to see all the possible queries that are out there. Notice here that the schema along with the types are represented in this documentation. Let's now include more fields in our query. If you're unsure about what is available, if you hit Control Space, you can see all the available fields that you can add to this query. So I'm going to go ahead and add the bio, and let's see if we have something like an ID that we can add. There it is. So we can add an ID. And we can also see any other field that we can add to our query. There are plenty of fields in this API that we can query for, and I'm including the name in our query. I'm hitting the play button now because our query is all set, and on the right side we get the JSON response back for our query. All of the JSON response is wrapped inside the data object, and you can notice that we got exactly what we asked for. GraphQL just does that. Remember that you can also integrate graphical within your own projects, and it helps immensely for testing and querying purposes. Another cool feature in the Graphical Explorer is that if you didn't indent your query correctly, you can always hit the Prettify button and it takes care of your query's indentation. I'm sure you're excited. Let's learn more in the next clip. To the fields that you're
Hello everyone, thank you for joining how you implement disaster recovery. To do that, we're going to start out with this. This is a high availability architecture. This is a three-tier architecture, and it's deployed across 3 availability zones. That's what's going to give us our high availability. And as you can see, at all tiers, it has that redundancy across availability zones. At this tier here, you have NAT gateways that are deployed across multiple availability zones. The elastic load balancer, even though the diagram doesn't quite show it, is deployed across all 3 availability zones. Our actual compute layer, these EC2 instances, our servers, are deployed across all 3 availability zones. And at our data layer, we're using a relational database here, Amazon RDS specifically, and it's got a primary in one zone and a standby in another zone. So if that primary fails for any reason, it's going to fail over to that standby. So that gives you a very resilient, high availability architecture. These services here are S3, our object storage, and DynamoDB, our NoSQL database. Well, the important thing is backups, data backups. We're going to keep hitting this over and over again. If you have, so we're going to discuss those options in detail. Number 1 is an active passive strategy. With an active passive strategy, all your users are being sent to a single region where you've stood up your workload. That's the active region. But you also have a passive or standby region where you actually might not be running your workload. They're actively running it, but you have the ability to stand it up. As you can see, these EC2 servers are there, but they're not yet operating. The data's there, but it's backed up and needs to be restored. So what happens? Happens if there's a failure in this region is you switch over to your passive region, you light up your infrastructure, you restore your data.
I did actually want to look at this because this is...
Are you finding yourself going around and around and around from one tutorial to another Udemy course to another tutorial, always constantly moving from one tutorial to another, but never really feeling like you're actually making progress in...
Who here feels like that? Press 1 in the chat. I actually want to see this. There are more ones than I was expecting. Notice that I said press 1 in chat if you feel like this, and a bunch of y'all dickheads were like, I'm gonna press 0. God, I'm so good at this game. Look at me go. Okay, well let's do this one.
Your growth as a junior developer. Well, I hate to break the news to you, but more than likely all of those tutorials you're doing are actually killing your growth as a junior developer. In this video, I want to talk about why that is and how you can actually make better use or the best use of those tutorials as you're watching them and as you're working with them. Don't forget, if you have a question that you'd like to ask or a topic that you'd like me to cover in an upcoming video, leave a comment below or head over to
You'll light things
devmentordave.com and
into
fill
your
out the
eyeballs
Ask Dave
immediately.
form. Hey Junior Devs, Dev Mentor Dave here, helping you bridge the gap from learning to code to launching a successful career. Now there are thousands and thousands of tutorials online for almost anything that you want to learn, not just how to write code.
All right, I am going to speed it up a little bit because I'm so used to listening to things fast, and I also speak pretty fast that we have to go faster. By the way, if you didn't know, having a bookshelf in the back increases your credibility by like a significant amount.
But anything from learning how to talk well to learning how to fix a car. I even have a t-shirt that says certified YouTube mechanic because that's
Yeah.
where I go when I need to find out how to fix my car, right?
Plus
so
two
there's
IQ
lots
minimum.
of different ways that you can get information, that you can be taught how to do things. And we see a lot of times these tutorials either on YouTube or a paid subscription like Udemy or something like that. And a lot of junior developers can get caught up in this never-ending cycle of watching and copying these tutorials. And it really actually ends up hurting them in the long run because they
Okay,
spend
yeah.
a lot of time
We've
not really
established-
focusing on the things that are going to help them. So let me explain why, in my opinion, tutorials
Let's go.
can be a good
Come
thing,
on.
but in excess, they really can stunt your growth as a junior developer. The first thing to remember is that a tutorial is teaching you information. It's not really teaching you a skill. It's teaching you
Okay,
about
fair
something.
take.
It's teaching you about
Sort
a
of.
language, or it's teaching you about a framework, or about a tool. It's teaching you about things. It's not necessarily teaching you how to actually put that into action, how to use this. Now, do they have examples? Absolutely. I'm not saying that they don't do anything for you in that department, but really what they're trying to do is help you understand something. They're using the examples so that you understand a concept, or that you understand what a language does or what a tool does. They're not really there to help you build your skill set using that tool.
Okay, so I actually do agree with what he's trying to say here. So let me rephrase it in a way that I think what he is trying to say. And it's something that I've said many a times in the past, which is tutorials are really good if you already know what you're doing. Tutorials are not good if you don't know what you're doing. Now you're probably thinking, what is it? Hold on, whoa, back it up. That doesn't make that makes no sense what you're just saying right there. It absolutely does. Why don't you just chill out, okay? Chill out, Twitch chat. And what I mean by that is that when you already know how to use something and you look at a tutorial, you know about all the different places in which something is falling apart, where errors can happen, and all that. So when you see somebody else use it in a different way, it really does help you a whole bunch if you already know. If you don't know, though, it's just all magic and you completely shut up, okay, about Discord, okay, this is how it works. But really, like, if you don't know what you're doing, a tutorial can be like a nice stepping ground for you to take what you've learned and try to expand it a whole bunch or build something of your own. But it is like not that great of a place just to simply learn in of itself. And you really do have to go somewhere with it.
You're going to remember how to ride a bike years down the road, even when you can't actually still physically ride a bike. You're going to still remember how to ride a bike if you learned that skill. But just because you memorized all the presidents in order doesn't mean that 30 years from now you're going to remember all those presidents. And unfortunately, that's what most tutorials really are.
I don't really like that comparison. I mean, I see where he's going with it, which is there's like a head knowledge and a practiced knowledge, right? A head knowledge is the fundamental, like, base take of practice knowledge. You have to have the layer, right? You have to know how to do how things work and then put it into practice. But I don't know about I didn't really like that. I didn't really like that.
They're teaching you information.
L take is an invite to chime in. No, if I see some level of chat that's actually non-zero IQ, I will engage with it. Ability to be a launching platform, right? Being able to actually become good at something. Like, I totally am. Look at this. I still remember this. Identity, scale, rotate, orbit, translate. Boom. How great is that? And that's from X and A stuff, right? And so, like, did I get something out of it? Absolutely, I got something out of it. That was thing is the way to go. Honestly, I hear this all the time. I hear it constantly. Okay, no Sasha Grey Craigasms in the chat. Real talk. Who here thinks it is? Type 1. My hot take, I don't think the docs are great for with the server. You read the effing docs, and then it helps a ton. Because it gives you a bunch of answers right off the rip, and first off, they also just may be completely incorrect answers. You don't even have enough experience to know that they're incomplete. But the process of learning requires you to do a little bit, struggle, fail, find an answer. Do a little bit, struggle, fail, find an answer. Do a little bit, struggle, fail, find an answer, right? Like, that's really the process of learning. That's what makes a good tutorial. Well, that's actually what makes a bad and good tutorial, is that at the end of the day, you make this really nice tutorial. You've just skipped over all the parts where you failed and learned. Whereas with ChatGPT, you don't get any of that. You get almost none of that, right? It just kind of gives you the answer, and you don't actually have any of that struggle or learning phase, right? None of it really sets in. ChatGPT is terrible learning code because you need to know enough to know when it's wrong. Yeah. I mean, see, that's the hard part.
Try to understand what they're talking about, and then hit the pause button before they show you how to actually use that in a real world example.
Yep.
And then go over to your code editor and actually try to do it yourself. What this does is prove to you whether or not you really understood everything that you just listened to. Because if you can listen to something and then you can take the time and think through it and understand, how am I going to put this into action in the real world, in real code, that is a huge boost to your success. It's a huge boost to your confidence to be able to then hit the play button and see that they did the same thing that you just did. Another thing you can do to make tutorials successful for you is to not do the example that they give. Instead, do something completely different.
Is he telling me just to
we don't
follow
want to
the
just
tutorial?
copy what the person teaching us is doing, because we're not actually really putting it into use. It's not something that we've thought through. We're just following along somebody else in their process. We want to take the time to...
That's why I've always said that I worry about something like Copilot as well. Copilot is really great because I can get started and rip through code, and I can go to a new language and kind of like get through it pretty quickly, because I generally know when something is correct. You know, like if I open up Golang,
Different scenario.
Growth is when you maintain something beyond just its initial conception. You know, I always say that I don't care if you finish a project and all that. Absolutely. The point of doing little side projects and stuff is to learn what you like, to learn what's out there, to be familiar enough with it to talk about it. But if you want to become an expert, it takes more than just learning about something. You got to spend years trying to do stuff. And I think that's the mentality that a lot of people don't have, is the difference between understanding, being able to talk about something, and being a master of it. And to be a master, it just takes forever, right? It takes...
Are you finding yourself going around and around and around from one tutorial to another tutorial?
Oh no, I got triggered on Twitter again. I saw a tweet that I hated enough to sit here and complain, because I feel like most of the conversation about backend versus frontend sucks. It just doesn't capture the nuances or the reality of shipping software. As soon as we get into the
Anxiety in tech.
So you're scrolling on LinkedIn, and one of your previous interns just got into Google for a colleague of yours. You don't need to study anymore. You don't need another book, Udemy tutorial. Stop looking for the perfect programming language. Notion note-taking system. Get off Reddit, get off YouTube, get off Twitter. Open up VS Code and just write. If you know how to write a function, you already know enough. You just need to sit down and write code. Don't learn, then build. Build, and you will learn from that.
or a total of 50 people, or just 3 in this case, we might define our structure then as containing those people as simply an array. And if a person is a data type that we've defined in week All right. This is CS50, and this is week 5. And among our goals for today are to revisit some topics from past weeks, but to focus all the more on design possibilities, particularly by way of data structures. So data structures, again, is this way via which you can structure your data. But more specifically in C, it's like how you can use your computer's memory in interesting and, dare say, clever ways to actually solve problems more effectively. But we're going to see today that there's actually different types of data structures, and we'll make the distinction between abstractions, like high-level descriptions of these structures, and the lower-level implementation details, so to speak. So in particular, we'll talk first today about what we call abstract data type. So an abstract data type is kind of like a data structure, but it offers certain properties, certain characteristics, and it's actually up to the programmer how to implement the underlying implementation details. So for instance, there's actually this abstract data type that's common in computing, known as a queue. And from the real world, most of us are presumably familiar with queues, otherwise known in the US typically as lines or forming lines. In fact, I have here three bags of cookies. Could I get like 3 volunteers to come up on stage and queue up? Okay, I saw your hand first. How about your hand second? And in the blue, light. Okay, come on down, just you 3. And if you could kindly come on up. Come on up. Yep, there's our blue. Come on over, and if you want to queue up over here, if you could. Come on down. Thank you. As we begin, do you want to introduce yourselves first? Okay. All right, next.
Not sure mechanical or electrical yet, but one of the two. And I'm currently in Canada.
Nice to meet you.
Hi everyone, I'm Isabella. I'm in Strauss, and I plan on majoring in computer science.
Wonderful. Well, welcome to all 3 of you. And I think this will be pretty straightforward. I have here these 3 bags of cookies. You formed nicely this line or this queue. So if you'd like to come up first and take your cookies. Thank you. And right that way. That's all there is to this demonstration. Your cookies as well. Right this way. And your cookies, right this way. Wonderfully well done. Thank you to our volunteers. The point is actually sincere, though. Simple as that demonstration was, and as easy as it was to get those cookies, queues actually manifest a property that actually is germane to a lot of problem solving in computing and the real world. Specifically, queues offer this characteristic, FIFO, first in, first out. And indeed, as our volunteers just noticed, as they queued up on stage, 1, 2, 3, that is the order in which I handed them their cookies. And dare say it's a very equitable approach. It's very fair. First come, first served might be a more casual way of describing FIFO, first in, first out. But there's other ways to store data, especially as data is coming in to a computer system. And we might also describe data as being known as, let me rewind. As for the Now, structures like these actually offer specific operations that make sense. And in the context of queues, we generally describe these operations as enqueuing and dequeuing. So when our first 3 volunteers came up, they enqueued, and as I handed them each a bag of cookies, they dequeued and exited in that same order. Now, how could you go about implementing a queue in code, specifically in C? Well, we can actually implement it in bunches of different ways, but perhaps the most obvious is to borrow our old friend, namely arrays, and we could use a data structure that looks a little something like this, whereby we specify the total capacity of this data structure. For instance, we might store a total of 50 people, or just 3 in this case. We might define our structure then as containing those people as simply an array. And if a person is a data type that we've defined in weeks past, you can imagine each of our volunteers is indeed a person, and we've stored them one after the other contiguously in memory by way of this actual array. But we do need to keep track inside of a queue using one other piece of data. Namely, we need to keep track of an integer like the size, like how many people are actually in the queue at this moment. Because if we have a total capacity of 50, I'd like to know if I only have 3 volunteers, that I can do some quick arithmetic and know that I could have fit another 47 people in this same queue. But it's finite, of course. If we had 50 volunteers all wanting cookies, that's as many people as we could actually handle. So there is this upper bound then on how many we could fit. But there's yet other ways for storing data inside of a computer's memory, and there's this other abstract data type known as a stack. And stacks are actually omnipresent as well, even though it's not necessarily the system you would want when you line up on stage. For instance, could we get 3 more volunteers? Okay, I saw hands here, and right here. Come on down. We'll have the orchestra come up this time. All right, come on over. And if you wouldn't mind, come on over. We'll do introductions first. This will be almost as easy as the last one. If you want to introduce yourself, and let me just stack you against the lectern this time. So if you could go there, and if you could come over here, and if you could come over here, we'll stack all 3 of you. So you were first, so you're first in the stack.
Hi, I'm Syal. I have no idea what I'm studying, and I live in Strauss.
Wonderful. And next?
I am Tanai. I'm studying Econ and CS, and I live in Canada.
Hi, I'm Claire. I want to study applied math, and I'm in Wigglesworth.
Wonderful. Welcome to all 3 of you. And if I may, let me just advance a bit more information about stacks. The catch is that stacks actually support what's known as LIFO, so last in, first out, which is sort of the opposite, really, of a queue or a line. So in fact, you were last in line. So here we have your cookies. Thank you so much. If you'd like to exit that way. We have your cookies here. Thank you so much. We'd like you to exit this way. And even though you were first, like LIFO doesn't really give you any cookies because you're first in, not last in. And so, yeah, okay, points made. We'll give you their cookies. All right, so thank you to all 3 of our volunteers. But LIFO, suffice it to say, doesn't offer the same fairness guarantees as a queue or a line more traditionally. And imagine just go lining up in any store or the dining hall or the like. Ideally, you want the people running the place to adhere to that queue, to that line, so that FIFO is preserved if you indeed care about being first. Whereas there are contexts in which LIFO does actually make sense. In fact, if you think about Gmail, your inbox, or Outlook, typically you're viewing your inbox as a stack, right? Because when you get new mail, where does it end up? It actually ends up on the top, and the top. And if you're like me, odds are, which emails do you tend to first? I mean, probably the ones on the top, the ones that came